Good day to all of my grade 6 students. Welcome to the third day of our distance learning class in Mathematics 6. Now, today we will be discussing lesson number 2, which is all about, as you can see on the screen, it's all about evaluating algebraic expressions. Do not forget to write the lesson on your notebook and, of course, the date, April 1, 2020. I'll give you 5 seconds to write it on your notebook. Okay, just like what I've said to you, our lesson is all about evaluating algebraic expressions. To start with, in this lesson, I have divided it into 3 parts. The first one is the warm-up exercise. The second one is the past question of the day, and the third one will be our lesson proper or the lesson presentation, including the activities and examples that you will be doing today. Okay, let's start with our warm-up exercise. I'll be giving you 2 minutes to do this warm-up exercise. This is just by simplifying expressions by, of course, following the order of operations that we have tackled in the previous quarter. So as you can see, there are 5 questions and you will be answering it in 2 minutes. Answering them rather in 2 minutes. So I think you're ready. Okay. Your timer starts now. Please write this one on your notebook and answer them properly. Thank you. So I'll come back after doing this activity. Do this one in 2 minutes. I'm looking at you. Oh, you still have 48 seconds to do this. Okay, 5, 4, 3, 2, and 1. Okay, let's start answering number 1. What do you think is the answer for number 1? The answer for number 1 is 34. Now, how did you get 34? We just multiplied rather 5 and 7, which gave you 35 minus 1, and that's equal to 34. Now, for the next one, okay, first thing that you have to do is to subtract 18 minus 11, and 18 minus 11 is equal to 7, and multiply it by 7 is equal to 49. Next, you do multiplication. 17 times 8, okay, then add it with 3, okay, add 3 and add 22, okay, the answer is 161. Now for the next one, what you're going to do is to do what is inside the parentheses. So 40 minus 35 is 5, multiplied by 15, so that's 75, then add 36, that's 111. For the next one, 12 minus 4, okay, so you have to subtract 12 minus 4, the answer is 8, then multiply it by 7, by 7 rather, it's 56. Then simplify 3 to the third power. If you simplify 3 to the third power, it's just like writing it like 3 times 3 times 3. So that's 27. 27 plus the product of 7 and 8, which is 56, it's equal to 83. Now count the number of checks you have, write it on your notebook, send it in the assignment portion of your Google Classroom. Attach there and I will be checking it. I'll be recording them later, I should say. Okay, let's proceed now to the next part. The next part is the past question of the day. So the question is, what is the corresponding algebraic expression of the mathematical phrase, the sum of the reciprocal of x and y? I'll give you 1 minute to answer this question. Your timer starts now. Okay, time's up. So please send your answer in the assignment portion. Have a snapshot of your notebook and send it there. I'll be checking it later. Okay, let's proceed now to our learning objective. Write this one on your notebook. Evaluate algebraic expressions. So this will be the objective that we will be learning for this day, or I mean targeting for this day. Okay, I hope you already wrote this one on your notebook. Let's unlock the different words or important words that you will be encountering later. The first word is variable. Constant, second is constant, algebraic expression, and evaluate. Now I have here one example. Ron Howard was born in 1954. You can find out what year Ron turned 16 by adding the year he was born to his age. So how we're going to write this one is like 1954 plus 16. Now take note, in algebra, letters are used or often used to represent numbers. You can use a letter such A to represent Ron Howard's age. When he turns 8 years old, the year will be 1954 plus A. Now, what are we going to do now is to identify the different parts of the expression or the equation. Take note that the letter A has a value that can change or vary. When a letter represents a number that can vary, it is called variable. Please take note. Variable could be a letter or any letter that has a value that can change. Okay, take note of this. The letter, okay, that has a value that can change. That is what we call variable. Or it could also vary. It could differ. Now, the year 1954 is a constant variable. Okay, if we say constant, it does not change or it cannot be changed. That is the definition of constant. Take note, we have variable, could be a letter that has a value. Okay, take note of that. And in our expression a while back, which is 1954 plus A, your variable is A. okay? And 1954 is your constant. It cannot change. Now, let's define also algebraic expression. Algebraic expression consists of one or more variables. Take note of this. Consists of one or more variables. It usually contains constants and operations. For example, 1954 plus A is an algebraic expression for the year Ron Howard turns a certain age. Okay, let's go to this table. As you can see, we have here year born plus age is equal to year at age. You can see below, okay, the expression is 1954 plus A, okay, where A is the age. So what you're going to do to find the year at age is just to substitute A with a given age. Take note that age here is our variable, and the definition of a variable, okay, it can be changed and it could vary, or it can be, yeah, it could vary also, or it could differ. So A could be 16, A could be 18, 21, or 36. So in order for you to get the year at age here on this column, you will just add the year born plus age so that you will know the year, okay, when he will be turning 16, 18, 21, 36. Okay, the year, okay, when he will be turning 16, 18, 21, 36. Now, if he will be 16, it will be on 1970. 18, it will be 1972. 21, it will be 1975. And if he will be turning 36, it will be on 1990. Just add, okay, the year he was born plus his age, and you will get here the year at age. So you will see here. Take note, A is your variable. It could vary, it could be changed. Take note of that. And always remember to evaluate an algebraic expression, substitute a number for the variable. A is your variable, take note of that, and you can substitute by any number. Okay, take note of this. I hope you got it. Okay, let's proceed to an example in evaluating algebraic expression. Evaluate k plus 9 for each value of k. Now take note of this. Your k is equal to 5. Okay, so let's take k plus 9. This is your expression, k plus 9. So what you're going to do is to substitute 5 for k. So you will replace k with 5. So take note of this. So k now is replaced by 5, then add it with 9. So the answer is 14. Okay, can you do letter B? So k plus 9, substitute 2. Okay. So it's 2 plus 9. Then add, it will give you 11. Okay, again, I'll repeat the step. Substitute, then add. Okay, again, let's repeat letter A. So k is equal to 5, and the expression is k plus 9. So in order for you to replace k, look at the value, which is 5. Okay, then substitute k with 5, then add it with 9. 9 here is your constant. So 5 plus 9 is equal to 14. Now for the second example, k is substituted by 2 because k is equal to 2, then add by 9. So the answer now is 11. Okay, can you do this one? A plus 6 for each value of a. So a is equal to 3. So again, a plus 6, substitute 3 for a, so that's 3 plus 6, then add, it's 9. A plus 6, a is equal to 5, substitute, that's 5 plus 6, the answer is 11. Now, for multiplication and division of variables, it can be written in several ways. It will be shown in the table given. So for multiplication, take note of this, that the constant, okay, will just be written, okay, beside the constant rather will be the variable without any operation. Take note, it could be written like this. 7 times t, or 7 multiplied by t. Or it could also be with the use of a raised dot, or an open or a closed parenthesis, or with the use of your times sign. Same like this, same as this. Sorry. Okay, take a look at the examples. For division, it could be written as q over 2. Could be written like this, or with the use of your operation. Same with these examples. When evaluating expression, use the order of operations. Always remember the lesson that we had during the first quarter, which is all about GEMDAS or PEMDAS. You should apply that one in simplifying expressions. Okay, additional example. Evaluate the expression for the given value of the variable. So we already have here 4x minus 3. 4x is equal to 2. So what you're going to do first is to substitute 2 for x. So 4, substitute x, okay, so it's already 2 minus 3. Now what's operation is this? It's multiplication. So what you're going to do is just to multiply 4 times 2, which gives you 8 minus 3, so subtract, so the answer is 5. It's so easy, right? Now, next, x divided by 5 plus s, where s is equal to 15. Again, substitute all s, okay, with 15. Then afterwards, do the operation. So 15 divided by 5, I'm so sorry, plus, okay, s, which is still 15. So do the operation, or I mean the order of operation, you divide first. 15 divided by 5, okay, is 3, plus 15, then add, it gives you 18. Now next, 5x squared plus 3x, where x is equal to 2. So again, substitute x with 2. So 5 times 2 squared plus 3 times 2. Then evaluate the power. Always remember, you have to do what is written in the order of operation. You have to do what should be done first, which is the exponent. Of course, we don't have group here. So exponent. So 2 raised to the second power, that's 4. So 5 times 4 plus 3 times 2. So then multiply. The answer is 20 plus 6, which gives you 26. Take note of this. You should do this one first. Okay, exponent first, then do the multiplication rule. Next, 3x minus 2, 4x is equal to 3. Can you do this? Okay, do it now. Okay, good. So first step, substitute x. So 3 times 3. So we already substituted x with 3 because x here is 3 minus 2. Next, multiplication. 3 times 3 is equal to 9. Subtract it with 2. The answer is 7. Okay, do this one on your notebook. Do it now. And let's see if you will get the correct answers. Okay, let's answer now. So R, substitute R with 12. So 12 divided by R, I mean 12 divided by 3, I'm so sorry, plus again, we have R here, so it's 12. Take note, we substitute R with 12. Okay, so what are we going to do next? Follow the order of operations. So we have to divide first 12 divided by 3. Okay, of course it will give you 4 plus 12. It's 16. Then do addition. Next, substitute 3 for y. So 4, so y here will be substituted by 3 even here. So it will be 4 multiplied by 3 to the power of 3 plus 2 multiplied by 3. Again, you do first, okay, the exponent. So 3 to the second power, it will give you 9. Okay, so multiply now. 4 times 9 plus 2 times 3. So multiply 4 times 9 is 36, then 2 times 3 is 6, then add. Just follow the steps given. Okay, last, I think this is the last one example. It's for division. Again, substitute 3 for A and 2 for B. So this one will be changed into 3 and B will be changed into 2. You'll see here the error. You can see here already that we have 3 here and we have 2 there. Again, what are you going to do? You can simplify this one or you can do this one as well at the same time. So 6 divided by 3 will give you 2 plus 4 times 2 it will give you 8. Okay, then 2 plus 8 will be 10. I hope you get this example. Now next, same process. Substitute W and substitute I'm so sorry, X. So as you can see already, W is substituted by 4 and X is substituted by 2. Then simplify. Again, divide and multiply from left to right. Or you can do it at the same time. 8 divided by 4 gives you 2. And 2 multiplied by 2 will give you 4. Okay, I'll repeat. 8 divided by 4 gives you 2. 2 times 2 gives you 4. And add, so the answer is 6. Okay, I think you're now ready for our lesson quiz. Okay, to apply the different ways on how are we going to simplify algebraic expressions. Now, after answering this lesson, please just send your answer in the assignment portion of your Google Classroom